now we go back, and now we're going to do the oil spill, which is Rushi pouring a cup of warm water into the room temperature water. So let's see that happen. So you can see pouring it. And now you'll notice there we get a standard deviation alert, and that was from our graph where the orange line broke the range for the acceptable boundaries, and then up top you'll notice the blue line also did, so we actually got a mean alert after that. If you go back, now it says mean alert. And then we're going to stop testing. And that's it.
Did you do any testing in the ocean?
No.
Well, how do you know that a bucket of water with some oil in it has any relevance to what might happen in the ocean?
Well, I mean, we specifically didn't do, us personally didn't do any testing in the ocean, but we do have video, infrared video from the same camera of what it looks like in the ocean. So we can see that it gets brighter in the ocean. So, I mean, it does. Our algorithm, what it's detecting is significant and like it has to be a persistent change in the infrared video feed. So anything that changes the infrared video feed by a significant margin, which is determined during the calibration phase, and it stays there for long enough, we'll set off the algorithm. So in the ocean, if it doesn't look exactly the same as the water, it's fine. It'll still detect.
Yeah, but I think one of the things we learned from this Gulf oil spill is that the oil doesn't necessarily come to the surface.
Then this is not the system to use. This is just cameras filming the surface of the ocean. If you're trying to detect something underneath the surface of the ocean, then this doesn't do anything. It's a visible infrared camera.
How do you determine those thresholds?
Okay, so during the calibration phase, what it's doing is it's collecting those end frames, and in that region, it takes the mean pixel value and the standard deviation value. So you have a value for each frame for the mean and standard deviation. And then the mean was those blue lines and the standard deviation red. So let's go to the mean. So now you have an array of mean values. You take the mean of that, so that's so you take an average of that, and then you have the standard deviation of those mean values. And the upper bound is the mean plus some weighting term times the standard deviation, and that weighting term is selectable by the user in the configuration dialog. And the lower one is just the mean minus that same weighting term times standard deviation. And then we do the same exact thing for the standard deviation. Yep.
Yeah, I started 3 minutes ago because the battery died. To restart it. So I can qualify on Google. No, there's some video in it.
Right. Yeah, so
these are done.
right, which is why we have those. Which is why we have the user selected parameters for the standard deviation. So if you lower that parameter, then basically if let's say the image is changing more during the calibration phase, then you would basically want to lower the standard deviation weighting term. So otherwise that range will be huge if the image is changing during the calibration. But if we're using like a still image during that, because we don't have waves, so we have a fairly high weighting term there. But if it's changing, then you would want to lower the weighting term so that range is so that it shrinks to still acceptable. And we're also using past end frames. That's to deal with noise like that, so that it's not just if you have a noisy frame like from a wave that occurs or something, then that's fine because we're averaging a series of frames.
So my comment is that you seem to have a detector. Normally we classify detectors by a couple of statistics, and I was curious whether you knew what the receiver operating characteristic looked like. Namely, do you have what kind of false alarms and what do you have any idea what your probability of false alarm would be here, or what your sensitivity to what level of perturbation you're able to detect?
it and seeing how us doing things affects the results. So we don't have a set of like ocean data that because we never went out to a rig or anything to collect data.
Do you think that day and night cycles will affect water temperature, and might that trigger false alarms?
Yes, we have considered that, and that's why they would have to recalibrate at night before, and we're also planning to implement one additional feature that was introduced very, very late, which is auto recalibration. So that's just it's not gonna take very long to implement that, but we're just gonna do that before we give the product to our customer. Yes.
How is, you show a picture of an oil rig. How do they detect oil and water now, and what additional features would your system provide to that problem?
So right now they check it visually. They have people just looking. So sometimes they have, if it's unmanned oil rig, they'll have helicopter flyovers. So they'll, which costs a lot of money. They have to fly a helicopter every couple of days and look to make sure there's not water. They also have people in boats going around checking, see if there's oil. So this obviously would be more convenient if they have an automated system. I think our customer is actually planning to do some tests this summer with the system to see how it works on the oil rig. But to start off, it would be a user-operated system, so there still should be a user there. It's definitely not in a stage in which it can just fully replace anyone having to check. So you still have to check. But if you ran this and then also checked, and you decided that this could detect just like well enough, maybe you could decrease the number of times that you have to have a helicopter fly over or go around it and boat.
What sort of standoff distance does this work on? I mean, in the lab, you're maybe a meter away from your tank. A helicopter might be hundreds of meters or more.
You can adjust the zoom. You can adjust the pan tilt and zoom, so you can zoom in if it's farther away. You can zoom out. The user has the ability to set up however they want.
And does that change the calibration and sensitivity of this
Well,
detector?
no, because what you would want to do is you want to set it up first and then calibrate, so it's calibrated on that setting that you've chosen.